In the first part of this program, we had discussed about the conventional or non-renewable sources of energy. But in this part, we shall be discussing about the non-conventional, also called the non-traditional or alternative sources of energy. These sources of energy are renewable and will continue forever, and therefore, it is advisable to make maximum use of these forms of energy as, when and wherever they are available. Some of the important sources of this type of energy are
solar energy. As per an English saying, all life is bottled sunshine. Actually, wood fuel and coal are indirect products of solar energy. Green plants have the property to trap solar energy and store it in the form of wood through photosynthesis. India, being a tropical country, receives sunlight in plenty. Deserts of Rajasthan receive 20 megawatt solar energy per square kilometer hour. Solar energy is harnessed in the following ways. Solar cooker. In a metal box which is painted black inside to absorb and retain heat. The lid has a big mirror reflection surface to reflect the heat from sun into the box. The box contains black painted utensils in which the food to be cooked is placed. Solar cookers are supplied at subsidized rate to make them more popular. Several families in India are using solar cookers. The food cooked maintains vitamins and other contents in safe limits. There is no problem of smoke, but it has not gained popularity in the rural areas. Solar water heating. It is a rectangular box with transparent cover that faces the sun, usually mounted on a flat roof. Small tubes run through the box carrying the water to be heated. The tubes are mounted on a metal absorber plate which is painted black to absorb sun's heat. The back and sides of the box are insulated to hold in the heat. Heat builds up in the collector, and as the water passes through the tubes, it too heats up. In Israel, about 80% homes have solar water heater. In India, several hospitals and nursing homes have solar water heating system to ensure a supply of hot water. For this purpose, provision is made right from the beginning during the construction of a building. Domestic buildings can also have this provision at the time of construction. Photovoltaic cell or photocell. This is a device to convert sun's light and not its heat into electricity. Photovoltaic cells or photocells or solar cells are made up of two separate layers of silicon, each of which contains an electric charge. When light hits the cells, the charges begin to move between the two layers and electricity is produced. Solar cells are wired together to form a module. A module of about 40 cells is enough to power a light bulb. For generating more electricity, several solar cells are wired together into an array to meet the electrical needs of a home or to run a motor to lift water for irrigation. At present, photocells are costly because silicon crystals are costly, but greater demand can bring down their cost. Materials such as amorphous silicon are being tested to reduce the cost.
Photovoltaic cells are used in calculators and watches. They also provide power to satellites, street lights, highway lights, weather stations and other electrical systems which are located far away from power lines. Photovoltaic cells and other solar energy devices are eco-friendly, because they do not pollute the environment. And because of this, Japanese farmers have started using solar energy cells in place of insecticides to kill insects. But of course, photovoltaic cells and other solar energy devices will work only when the sun is shining, and thus they need batteries to store the electricity. Government of India has declared 150 villages as Urja Grams. These villages have solar street lights which are run by photovoltaic cells.
Solar thermal electric power. Solar radiation can produce high temperatures which can generate electricity. Deserts are considered as the most suitable sites for generating solar thermal electric power because they have low levels of cloud cover with little scattered radiations. Mirror energy.
In 1980s, a major solar thermal electricity generation unit was built in California, containing 700 parabolic mirrors, each with 2G reflectors, 1.5 meters in diameter, which focus the sun's energy to produce steam, which then generates electricity.
We should remember that the sun is the primary source of energy in our lives. We use it directly for warmth and drying food grains and other agricultural products. Indirectly, we are using it to provide food, water, fuel, and shelter. That's why the sun is worshipped throughout the world. The historical Sun Temple in Konark, Odisha, speaks of the respect of ancient Indian culture for the sun. Wind energy. Wind was the source of energy used by the sailing ships in ancient times. China, Afghanistan, and Persia used windmills in the remote past to draw water from wells for irrigation and to run flour mills for grinding corn. Denmark used windmills to generate electricity in the 20th century. These days, Denmark and California have large windmill turbine cooperatives which sell electricity to the government grid. In Tamil Nadu, there are large wind farms which generate electricity to the tune of 850 megawatts. In India, mountaintops and coastal areas have high velocity of wind, hence windmills are installed in such places. Wind power is basically the function of wind speed. A windmill is fitted with 3 blades at its top, which move due to the wind currents. This energy enters the generator to which these blades are connected. The generator converts wind energy to electrical energy. Windmills have been in use for a long time in countries like Germany, America, Denmark, and Spain. In India, they have been recently introduced. In India, there are 83 wind monitoring stations at Tamil Nadu, Andhra Pradesh, Gujarat, Karnataka, Kerala, Madhya Pradesh, Maharashtra, and Lakshadweep. The electricity generated in India through windmills is about 3,000 megawatts. The biggest wind energy project of Asia, amounting to 150 megawatts, is at Muppandol in Tamil Nadu. It is possible for India to generate up to 20,000 megawatts of wind energy. Today, India occupies the 5th position in the world in respect of wind energy. The first 4 countries being Germany, USA, Denmark, and Spain. The Department of Non-Conventional Sources of Energy looks after the wind energy program in India. The world capacity of wind energy by 2000 was only 17,500 megawatts. Wind energy is free from pollution problems except for bird kills and disturbances in TV reception. Hydroelectricity. It is also called tidal power. The water of rivers is converted in big dams and allowed to fall on turbines. The energy causing the movement of turbines is converted into electricity.
The world's first hydroelectric power dam was built in 1882 in Appleton in the state of Wisconsin in USA. In India, the first hydroelectric power dam was constructed by Tatas in the later part of 19th century and the early part of 20th century on the Western Ghats in Maharashtra. The electricity that was produced from these dams was used to run cotton and textile mills in Mumbai. High rainfall areas were selected and dams were constructed on rivers in the Deccan Plateau near the foothills of Sahyadri mountains.
In free India, several dams have been built by the government. The Bhakra Nangal was built in Punjab and the Hirakud in Orissa. In Mysore, a big dam was built on the Krishna river under the engineering skills of Sri Vishveshwaraya. These days, practically every state has one or more dams. Madhya Pradesh has the Sardar Sarovar Dam, the Bargi Dam, the Tawa Dam, the Gandhi Sagar Dam and the Narmada Sagar Dam on the Narmada River. Dams supply electricity and water for irrigation. It is due to the Bhakra Nangal Dam that Punjab has become the granary of wheat. Due to the Narmada Sagar Dam, the future of Nimar is going to change. Agricultural land has already become costly in these places. Dams are associated with the following problems: resettlement of displaced persons, loss of biodiversity, salinity of soil, and sensitivity to earthquakes. Some social workers like Sri Chandi Prasad Bhatt and Sri Sundarlal Bahuguna, the late Baba Amte and Sri Pandurang Hegde have opposed the construction of big dams for these reasons. It is therefore advisable to construct small dams with small hydroelectric generation units.
China has started the practice of constructing small dams. There are 60,000 small dams in China, generating about 13,250 megawatts of electricity, which meets the demand of electricity in China to the extent of 30%. Even European countries like Sweden, Italy and France and even US have started the practice of developing small dams for generating electricity.
Biogas. This is the gas obtained by the fermentation of biological waste material such as cattle and human excreta and water weeds like water hyacinth, water lettuce, salvinia, hydrilla and duckweed. Biogas obtained from cattle dung and human excreta and piggery refuse is called gobar gas. Gobar gas is a mixture of 63% methane, 30% carbon dioxide, 4% nitrogen and 1% hydrogen sulfide along with traces of hydrogen, oxygen and carbon monoxide.
Methane, being a combustible source of energy, can be used for cooking food or even for being converted into electricity. Methane was named as marsh gas by Volta in 1776 as it was seen coming out of marshy places like rice fields. Methane is also known as Clar gas, sewerage gas, fool's gas and biofuel.
2 to 3 cattle heads can produce enough gobar gas to provide cooking energy for a family. About 10 types of gobar gas plants are available. Every gobar gas plant has a digester. 5 to 6 kg of cattle dung is mixed with a bucket of water, and this mixture is poured into the digester of the gobar gas plant. Fermentation takes place due to bacteria, and the gas is collected in a dome from which it is supplied to the kitchen through a pipeline. In the kitchen, it can be converted into fire in a gas burner just like LPG gas.
One of the greatest merits of gobar gas is its versatility. Apart from cooking food, it can also be used for lighting, power generation, running refrigerators or tube well pumps, etc. A country like Denmark produces 15,000 megawatts of electricity from 15 farmers' cooperatives.
The material left after the extraction of gas from gobar or cattle waste is called spent slurry, which is very good manure rich in NPK, nitrogen, phosphorus and potassium, which are designated as critical elements for the plant life. It also contains significant number of bacteria useful to crops.
Countries like India and China are trying to install tens of thousands of biogas plants in villages. In 1996, 2.18 million families in India were using biogas. In China, 20 million households are using biogas even today. Biogas plants need a lot of space for installation. Hence, it is more popular in villages. People in big cities cannot use it because obviously of shortage of space. By 2003, about 29 lakh gobar gas plants were installed in India. Biogas is devoid of smell and burns with a blue flame without smoke.
Energy from solid waste. A lot of solid waste is produced in cities every day in the form of food waste, canning industry waste, maize cobs after threshing out grain, fish processing units and dairies. Altogether, it is called municipal waste. This can be decomposed and biogas liberated can be used for cooking food or converted into electricity. London has a plant which makes 30 megawatts of electricity a year from 4,20,000 tons of municipal waste, which supplies power to 50,000 families. In Germany, 25% of the landfills for garbage produce power from garbage. Japan uses 85% of its waste in a similar way, and France about 50%. Delhi has a plant to produce 3.75 megawatts of electricity, while Mumbai produces 6 megawatts electricity from solid waste. Some other places where solid waste is converted into electricity are
Molasses is a byproduct of sugar factory. Molasses contain 10 to 12% of sugar. It is fermented with yeast and ethyl alcohol is obtained. Chemically, alcohol contains hydrocarbons and is inflammable, and hence it can be used as fuel in place of petroleum. Brazil did this experiment successfully by making minor changes in the carburetor. Petrol 50% and alcohol 50% make a fuel called gasohol. It can be directly used in the engine of automobiles. India has permitted mixing of ethyl alcohol with petroleum to the extent of 5%.
Brazil and Japan have started cultivation of sugarcane for the manufacture of fuel alcohol. Raising sugarcane crops to obtain fuel alcohol is called petrocropping.
Melvin Calvin of California was awarded the Nobel Prize for Chemistry in 1961 for the discovery of Calvin cycle dealing with the dark reaction of photosynthesis. Later on, he suggested that resin of Copaifera pubiflora and milky latex of plants like Euphorbia were rich in hydrocarbons and therefore can be used as fuel in place of petroleum. These days, Euphorbia lathyris is being cultivated for obtaining milky latex to be used as fuel. Plantation of latex yielding trees to be used as fuel is called petroplantation or dendrothermal energy plantation.
The Earth's surface is 70% water. Solar energy is absorbed by the seawater and ocean currents are created by wind in the form of waves. Due to the waves, the sea is never silent.
System which is very useful, and at least it has been used at a few places like Rann of Kutch in Gujarat, as well as it is used in Reims in France, is what is called tidal power generation. What is the principle of tidal power generation? The principle of tidal power generation is when there is high tide, the water goes up, when there is low tide, the water comes down. If the water at high tide is stored and brought in stages to the point when the water as it is lowest pass through a turbine, one can generate electrical power. The next visual will make this thing a little clear. We see a basin 1, this basin 1 gets fulfilled or rather filled at high tide when the water level is higher. As the water level is receding, one empties the basin 1 into basin 2 through a turbine. This is during the high tide. Then during the low tide, the basin 2 is left undisturbed, and as the water comes down, you have water flowing from basin 2 to the sea through the turbine, and therefore it generates power. Thus one sees, and the same thing happens as the water level is rising. Therefore one finds that one gets variable kind of a power generation during a tidal turbine, but combined with a grid, this can be a useful option. Another idea which is very interesting is wave energy, because ultimately there is a lot of energy in the waves in the ocean. The water rises through large heights and one would like to make use of it. One thing we have to remember in the wave motion as it is on the surface of the ocean is that the waves travel horizontally while the water moves up and down, and it is this up and down motion of the wave of water which we will try to convert into energy. What we have is there is a rectangular floating platform which you see as a float here, and this platform is floating on the surface of the water, and as the surface of water goes up and down, this platform also goes up and down. It is guided by means of 4 pillars, as you can see, so that it maintains its position. Below these pillars we have flotation tanks, which means there are tanks in which we fill compressed air or just air. The flotation tanks stabilize the platform, which means it does not move around much. Now what happens is, as this piston moves up and down, it is used to compress air, and that air is filled in the underwater flotation tanks. The compressed air from the flotation tanks moves a turbine which generates electrical power. So one sees that the flotation tank serves 2 purposes. It stabilizes the system and it stores air which can be used for electrical power generation. You can store it even for longer times, and therefore guarantee for times when the wave power is not that much, and we do not have much of waves.
At present, India has only one plant in Tiruchendur in Tamil Nadu producing 1 megawatt electricity per day. There are much more possibilities for India in this field. Tidal powerhouses disturb tidal ecosystems of the coastal region by disturbing water, birds and fish.
The second interesting application we have is that it is known that as we go inside the earth, it gets hotter and hotter. The reason simply being is that the core of the earth consists of molten material at very high temperature and gives out heat. At many places in the world, there are faults which result in steam and hot water coming out of the earth as a geyser. This occurs even at places which are very cold like Newfoundland, Greenland, and there this steam and hot water is immediately useful for heating the buildings as well as for generating electricity through a wind turbine. The hot water is used also for heating the buildings as well as for other uses. At places where there is no natural geothermal energy in form of steam and hot water, what can be done is that we force water on the hot rocks which are below to give out steam, and this gives us steam at a good temperature and pressure which can be used for many purposes. The use of geothermal energy is either as electricity or as a heat and for refrigeration purposes.
In India, in Manikaran in Himachal Pradesh, a cold storage and a powerhouse are run by geothermal energy.